We're both based here in Dublin, Ireland, so it's pretty early for us. It's 7 a.m. We just had our morning coffee, so hopefully this will be a good presentation. So thank you for joining wherever you are today. We'll talk about Airflow as a dynamic ETL tool, and we'll really focus on why we're selecting Airflow and why we're using it as an ETL tool, and really what's our use case for doing that. It's not something that's specific to our environment, and I think it's something that is very generic and can be used in other workplaces as well because it addresses some of the common issues we've seen with a lot of different ETL tools. So before we jump in, we'll do a quick introduction. So for myself, my name is Hendrik Kleine. I'm an analytics lead. I was originally born in Singapore. I grew up in the Netherlands. I've been living in Ireland for past 14 years now. And during that time, I've had a variety of roles from business analyst to data analyst, managing data, data visualization, things like that. And I've worked for uh, a handful of really big tech companies, including Microsoft and IBM, and found that over time, really all of them have the same challenge, and that is leveraging the latest and greatest technologies and data, but still not having a great data landscape. It often is somewhat close to chaotic. They have so many different solutions that there's not one standard, and it's not possible to set a standard. So I think what we'll talk about today, from an ETL perspective, is how to navigate an environment like that, and how to implement something that's not necessarily a standard, but helps people move forward in a consistent manner anyway. So I look forward to talking about that today. And today with us is Vicente as well. Vicente, if you could introduce yourself.
Yes, hello everybody. This is Vicente. I work as data engineering lead in Optum. I have more than 1 decade working in data environments. So similar to what Hendrik was talking about, I have been working in companies like Ryanair, like Paddy Power, and always found it similar issues like many different databases systems, many different technologies, and always the same goal of trying to integrate all the data coming from those different sources into a central location. So similar to what Hendrik said, this is one of the reasons why we came up with using Airflow and try to integrate different technologies, different sources, and how to try to empower our users to be able to create those data pipelines is in an easy way for them and in a way in which they don't become a block for their daily works.
Great, thank you so much. So, in terms of the content for today, we'll really spend quite a bit of time on telling you a bit more about our environment, and that is so you can hopefully draw some similarities to your own workplace. So, we'll talk about the data environment that we have, but also of the different skill sets of the different people that work with us, either directly in our team or closely with us, and our objective to really make the most out of that environment and make the most of those people and those different skill sets rather than saying, hey, we need to do everything different and everything needs to be in airflow right now, and this is the way we're going to do it. So we'll talk a bit more about that, and hopefully you can draw then that similarity to your environment and maybe do something similar or exactly the same that we're doing today. We'll also talk a bit about how we transitioned away from Alteryx, which is one of our primary tools for handling ETLs today. And so it's a tool very similar to Microsoft integration services, if you've used something like that. And we'll talk a bit about the challenge for doing that. Obviously, Alteryx or integration services is largely drag and drop as a tool, whereas Airflow is clearly not. So, how to make that change happen. And so, we'll talk a bit about that and then also the different challenges that we face and the different lessons learned. So, this was definitely not a smooth transition. We hit some bumps in the road, and we are working on a second iteration of this particular platform to make sure that we do it better and better over time. So, like I said, the first part, we'll talk a bit about our background as to why we're doing this. And then at the end of this presentation, we'll talk about the application that we created on top of Optum BI, sorry, on top of Airflow. Um, and then look at the different methods that we use to create the DAGs automatically rather than creating the Python files itself. So with that, I'll talk a bit more about the environment. And I think it's a very generic environment. If you've ever worked for a big company in any different industry, it doesn't have to be technology. You can really see that there's a lot of different data stores for different data streams, for different services. Maybe you have different point of sale systems or transactional systems. Maybe you've acquired another company and inherited different systems from them. And so you end up with a lot of different technologies. In our company, for example, we run SQL Server, Oracle, Teradata, MySQL, Hadoop, Mongo. The list really goes on and on. And although that sounds really nice, and we have the ability to choose the technology that we want to do a particular project, um, it's not always great in the long term because we end up with so many different services for so many different purposes, and we segment the data in so many different ways. That's really hard to go back and find out where did the data originate, what was the purpose of this data, and are we duplicating this data in different places. And so the side effect of that, as well as then that data silo problem that we see in, I think, almost every company today, where we have multiple services providing the exact same data. And so that provides a problem because they may not always be in sync. You may run an ETL automatically here for one platform, you may run another one manually or on demand. And so we get all of these silos that are the same but different, or one lags behind, one is up to date, one isn't, one has calculated fields in it, the other isn't. And so our objective internally for us really is to serve data science and analytics. So we want to drive analytics models and we want to drive reporting and dashboards, and we have the objective that they all use a consistent data source, and we don't have a situation where we get conflicting information from different places. Um, and so, as we said before, we're looking to integrate these different data sources, and we have to be careful and mindful of the different technologies that we have today. And on top of that, we also have to think about security. So definitely each database has its own method for authenticating. If you're lucky, there's some integration with Active Directory, so we can do that easily. If you're not so lucky, then maybe you have to configure a custom driver to make that work. And so that already sounds a bit more technical, and it definitely is. And so our objective here is to make interaction with Airflow as easy as possible. And if you have to think about a custom driver and having to configure that, it already makes it a bit more complex and you moving in the realm of a data engineer role. And so the goal that we have for a new platform is to be able to integrate these data sources without having to be a senior data engineer, really. So finally, the stack that we are aiming to use mainly is using SQL Server as a storage for analytics. We use Alteryx as an ETL tool and then Tableau as a reporting tool. And so this is our current environment where we take data from different places, we combine them with Alteryx, we do our transformation with Alteryx. And the reason for that is because it's a lot easier to use Alteryx because of the drag and drop functionality similar to Microsoft integration services. And it requires technical skill, obviously, to do that. And you have to be, for example, able to write a query in SQL and be able to then paste that in Alteryx and use that going forward. But it doesn't require knowledge of Python, for example, something that's obviously essential with Airflow. And so it's a lot easier to use and it's a lot easier to roll out at scale to a lot of different employees without requiring everybody to learn Python overnight, requiring them to learn Airflow overnight. And we also have Tableau reports, which is our final output in some cases. And here we have people that are developing reports or consuming reports. They may be power users that are comfortable with using different data tools, but maybe not with ETL development. And so we'll walk through the different skill sets that these team members have and then find out what the best possible solution is that could serve every team member really, besides the data engineer that is comfortable with Airflow and with Python. So we have three key roles within our team. And within our company, we obviously have more roles, but we categorize them into these three different buckets, really. So we have the data engineer. You can think of that person as someone obviously interacting with Airflow. And we have business intelligence. That would be somebody that's creating the reports, creating analytical models, and creating dashboard outputs that our customers would eventually end up using. And finally, we have the business analyst, which really fulfills two roles for us. It's interacting between the customer and our technical staff, but also between the different skills that we have. So between data engineering and business intelligence. So if we think of a data engineer, really they're focused on building these data pipelines for analytics, data science, and automation. And the real bottleneck there is that they're limited by the number of people within their team. And I think that's always the case, obviously. But really, when it comes to engineering, that's a recurring issue that we see over time. And so typically, engineering resources are reserved for high priority projects, but not necessarily for something you want to do quickly or ad hoc. Then, when we think about business intelligence, um, it's more focused on building the dashboards once you have the data already, creating that logic for different KPIs, finding out trends over time, and maybe designing the data mart with the data that you have gotten from a data engineer. But then there's that bottleneck is still present. So a business intelligence developer can't necessarily do his or her job without engineering doing that job of data ingestion and the pipeline building before. So it's a bit of a gap we're trying to address, and with what we'll show you later on in this presentation. And then finally, we have the business analyst, which knows the business inside out, knows what data we need to ingest, why we need to ingest it, and can do the requirements gathering, and then bridge that gap between engineers and BI developers to make sure that the data pipeline output is appropriate for the warehouse or the data mart that the BI developer wants to build. So we looked at these three key roles, and I really considered how can we come up with a solution that leverages Airflow, which will drastically reduce the costs that we have of all the commercial tools that we currently use for managing our ETLs, our data pipelines, which are all commercial. And so there would be a cost saving, and it would also be easier to manage going forward as our skill set over time changes more and more towards the data science area. And so we'll have more and more people comfortable in the area of using Python rather than drag and drop tools, if you will, or writing SQL natively. And so what we wanted was a user interface in a web browser when users can just go there. They can orchestrate data ingestion and transformation. So meaning with orchestration, I don't mean the scheduling that Airflow does, but really create a DAG from scratch, and then orchestrate that in Airflow without actually accessing Airflow at all. And so you want to be able to say, I need data from this particular platform or for this particular use case, and I need it to be in this database so that I can do my modeling or my reporting. And then finally, you want to link your report to that particular ETL so that when anybody views your report, they'll be able to go back and say, hey, this is the ETL driving this particular report. And so if there's any issue or need for an improvement, this is the ETL that needs adjusting. And that's a gap we have today. That it's really hard to tell where data comes from sometimes. And it's also really hard to ingest data when you need it the most because we have that bottleneck with engineering. And so, in a really, really oversimplified view, what we've built is a drag and drop functionality in our web portal where users can select the source type. So, here you think about maybe it's SQL Server, maybe it's MongoDB, things like that. And so, we have all the drivers pre configured in a template for Airflow. And all the user has to do in the UI is just select from a drop down list which type would they want to use. Then they paste their query. So select something, something from this database. You just paste that there. If they want, they can then transform that. And we only have a number of very limited number of transformations, mainly surrounding joins. We can join, union, we can add or remove columns, we can make calculations for new fields, things like that. And finally, we select the destination type and the options. So maybe the destination type would be Microsoft SQL Server. Again, we use a templated driver, and then the destination options. Maybe you want to overwrite data or drop the table first, things like that. Then you can rearrange these components up and down if you have multiple source types. And really, the idea is then that this is the extent of knowledge you would need to create a DAG. So there would be zero need to know Python. There would be zero need to know Airflow. After you rearrange or arrange these components, which are all drop downs and free text fields, you can click submit and our system will create the YAML file for you. It will push that to Airflow and really make that available for execution immediately. So that's a bit about the background, the different roles that we have, which I hope resonates somewhat with what you have in your company. And at this point, I'll hand over to Vicente and we'll talk a bit about the actual solution that we implemented based on this idea.
Thank you very much, Hendrik. So yeah, the main thing is that after everything that Hendrik has explained, and if you remember the diagram that he was showing before about what is the typical data pipeline in our organization, you remember in the center, like the main part was Alteryx. So basically, our goal at the end of the day was you have different data sources, maybe Oracle, MySQL, SQL Server, and you want to integrate data from those different data sources into one central location. And that central location will be feeding the different dashboard and reports that business intelligence developers will create. So with our solution, what we are doing is replacing Alteryx by Airflow. So if you see now our diagram is exactly the same. You have different data sources. You have one central location where you want to put the data. Main difference is that now the orchestrator and the execution engine is Airflow. Additionally, some requirements that we had for our solution was to be able to define the DAGs using a UI for the users. We didn't want them to need to write any Python code because not, as Hendrik explained, not all of them are expert writing code. We wanted to be able to introduce any transformation that they needed into the data through a SQL command box. And we wanted them to be able to set different dependencies. So imagine situations in which you are integrating data from different data sources, could be SQL Server, Oracle, and you may have different dependencies. You want to load first the data from SQL Server, transform it, and then grab the data from Oracle and integrate it with it. So we wanted to add as well that functionality to be able to set dependencies in your data pipeline. And finally, to have the possibility of version control. So if you have created a data pipeline and you have modified it like 3, 4, 5, 6 times, to be able to come back in time and say like, okay, now my data pipeline is not working as I expected. I want to see what changed, or I want to see like 3 versions ago. So the main requirement for us was we want to integrate data from different sources. We want to be able to process data with SQL, and we want to be able to move that data to SQL Server. So for the first one, for the data repositories as source, what we did in our UI was to offer the possibility to the user to choose the type of the source, in this case, Oracle, SQL Server, and then specify different information, like could be the server where is the database to which we want to connect as a source, and the table. Even instead of the table, you could specify with SQL command you want to execute in that database for pulling the data. What is happening behind the scenes when the user is introducing that information is that the UI will be creating a YAML file. This YAML file will be pointing to the Airflow operator that has to be executed for doing that operation, and it will take the parameters from the UI. So imagine that you want to move data from SQL Server to Oracle or the other way around. So the user, what it will do is choose the source type as SQL Server. It will introduce what is the server, what is the database. I want to execute this SQL command for pulling data. And then the UI will grab that information And in the YAML file, we'll say like, look, I need the Airflow operator for pulling data from MySQL or SQL Server to Oracle. These are the parameters that I want you to use for the source database, and these are the parameters that I want you to use for the destination. Something that I wanted to make a note is that, as you know, Airflow has a lot of different operators. So this is not like we invented the wheel. Many of the operators that we will be using behind the scenes exist already in Airflow. For those ones in which it didn't exist, we created them. But 99.9% of them already exist. For the data processing is similar operation. Basically, what we do with our UI is asking the user in which database you want to execute the SQL transformation. So you have to introduce a server, database, what is the SQL command that you want to execute, and where you want to export the output. What is the database, the server, and the table where you want to export the output, and if you want to recreate the table or if you want to append the information. Behind the scenes, exactly the same. You are grabbing all the configuration parameters. The UI is specifying in the YAML file what is the Airflow operator that we have to use, and is passing the parameters. And finally, SQL Server as a destination. For example, it was, in our case, our central location where we were pushing all the data is similar. You have a specific Airflow operator for moving data to SQL Server. You just add different parameters, would be like server, database, service account to connect. And behind the scenes, what you will have is a YAML file with all that information. I will show later how that YAML file will look and how is done that transformation. So a final requirement found it after our first version of the application was version control. So something that I'm sure that it has happened to you many times is that you are filling a form in internet, in any web page, and you introduce something wrong in that form. You click submit, you get the error, like this field is wrong, or you didn't fill this specific field, and it forces you to start again from scratch the full form. So this is how it was behaving at the beginning, the UI for our users. So as you can imagine, the experience wasn't the best. So you were creating a data pipeline, you introduce like the source of your data, you introduce which transformation you want to execute, you introduce like where you want to output the data, and then you generate the UI generate for you the Airflow DAG. The problem is that once that this Airflow DAG is generated, there is a disconnection between the UI and the DAG. So when a user was coming back 2 days later and wanted to modify this data pipeline, he was forced to be introducing all the values again. So in order to fix this, we introduced our database where we are storing all the information for the data pipelines that the user have created, and at the same time we are archiving YAML file generators and DAG Python files generated for Airflow. So with this functionality, and this was key for us, one user can come back 10 days later and say like, I want to see my data pipeline that I created 10 days ago, and I want to be able to modify or to change the table to which I am connecting, or I want to change the transformation that I am executing. So this is something that we introduce it later in a following version. But it was funny because it was one of the first things that we didn't consider at the beginning, and we saw very soon that this was really, really necessary. So what is happening behind the scenes? Now you know what is our environment, what are the main issues that we have with different data sources, what we want to do, and what we want our UI to do. The question now is how our UI is generating this YAML file behind the scenes. So as Hendrik said before, the way in which we are doing it is with building blocks approach. So basically, you have two specific blocks that are mandatory. Basically is the default arguments and the DAG information for your DAG. So many of this information, we know it already. So when you are connecting to the UI, we know who you are, we know your email, we know who you work for, but there are other information that we are going to need. This information is a unique name for the DAG to be able to identify the DAG. We will need to know how often you want to execute this DAG. We need to know when you want to start, when you want to end up the DAG, the number of retries, all this information that is always global for your DAG. So once that you introduce that, you have the option to start including different building blocks. So basically, you have a source, you add one building block in which you specify, look, I want to pull data from SQL Server, for example. This is the server where I have my database. This is the database. This is the table, or this is the SQL command that I want to execute in order to pull the data. And I want to move this data to this other database that is in this other server, to this other table. What is happening behind the scenes is that our UI is generating this information behind. In this information, what our UI is doing is choosing what is the right Airflow operator for the operation that you want to do. If you want to move data from SQL Server to Oracle, our UI is saying like, hey, the operator that we need is this one specifically because we are moving data between SQL Server and Oracle. If, for example, what you are doing is loading an Excel file into a database, what our UI would do is choose another different set of parameters and another different Airflow operator. So basically, the UI is the one that is smartly, depending on the type of action that you want to do and the type of source and destination, deciding which Airflow operator we have to use. Additionally, all the parameters, all the information that you are including, like server, database, is included as a parameters in the YAML file. So in this example, you are loading data from one database to other. So you have source and destination database, and then you have like table query that you are executing and table where you're loading the data. For ingesting an Excel file, you have like the path to the file, the sheet that you want to use, the server, the database, the table where you want to load that data. And what the UI is doing is saying which Airflow operators you have to use. Imagine that you have a file in an FTP server that you want to download and ingest. Similar, you have your operation here in which you have different comments that you can add, and you have the Airflow operator that is needed for downloading from an SFTP server a file, and you just specify what is the path to that file and which user and password you have to use. And finally, for transformation, that is the last block that you can use, is exactly the same. You just include what is the SQL code that you want to execute, what is the server, the database where you want to execute it, and where you want to export the output. So we are offering the UI. You just have to introduce like what is the data that you want to move, where you want to move, but you don't have to do any coding. What is happening behind the scenes, the UI is choosing the right Airflow operator that you have to use and the parameters that you have to pass. So this is how the YAML file is generated. Let's go a little bit deeper through it. So as I said before, we have the default arguments that you're going to have for your DAG. So you're going to have who is the owner. We know that when you're connecting to the UI, we know who you are. I know that sounds very creepy, but you are connecting to the UI, you're already logged in. We know who you are, we know your email, but you have to introduce like, okay, when you want to start this process, when you want this process to end, the number of retries that you want to do, and basically the different tasks that you want to execute. For the different tasks, what I said before, we have very basic actions: moving data from A to B, execute a transformation over data in one database, ingest data. These are the building blocks that we have and are the building blocks on top of which we want our users to be able to execute the data pipeline that will be refreshing or loading the data needed for the reports. So again, this is not like we invented the wheel. You will see, if you look in internet, you will see many people that are already like using YAML or configuration file for generating automatically DAGs. The main difference is that we customized this for our specific use case, and we did it in a way in which a user was able to, using these very basic building blocks, build a full data pipeline. But as I said before, I'm sure that if you go and you look in internet, there are more people that are using similar approach or something like a configuration file, and they're generating programmatically an Airflow DAG. So, okay, our user goes to the UI, says what exactly he wants to do. The UI generated the YAML file behind the scenes. What is happening next? So now I'm gonna go through what will be the typical process that is happening behind the scenes. So first step always is our user going to the UI, and he has two options. He may want to create a new DAG, or he may want to modify a DAG that he created in the past. Depending on the action that he wants to do, the system will be retrieving DAG information from the version control. In this case, you can see it here, or it may be generating a brand new YAML file. So imagine that our user is modifying a YAML file, is modifying a data pipeline that he created 10 weeks ago. At the beginning, he was ingesting data from one database, but now he needs to ingest data from two different databases. This happens sometimes. So the step that for our user is that once that connect to the UI is going to retrieve the information from our version control for that specific DAG. Once that the user have this information, using the building blocks that we showed you before, he will be adding the additional information that he needs. It's like, look, I had data source A, but now I need data source A and B. He include the different building blocks and he click finish. Then the UI, what it's doing is generating the YAML file in the similar fashion that I showed you in the slide before. Once this YAML file is generated, first thing that the system is going to do is archive it. It's going to make a copy for version control. So each version of each data pipeline that a user created, the YAML file generated is always archived. This is because it will make our life easier if we need to roll back. Imagine that you create a data pipeline, there is something wrong, and you need to roll back. So with this, it's very easy to the user to go to the UI and say, like, I want to go back to the version before. This is not working for me. So first thing that the UI is doing before triggering any part of the process is archiving the YAML file. And as well, if you are modifying an existing DAG file, you are archiving as well the DAG file. So that way we are always having in storage the old version of the YAML file that the UI generated and the old version of the Python file that was generating taking this YAML file. Once that everything is archived and we have the old version of everything, then we trigger the YAML file processor. This YAML file processor, if you remember the YAML file that I was showing, is really, I'm not going to say trivial, but it's a process that is very easy to do. I'm sure that many of you are already creating, when it's a very repetitive DAG, you are creating it programmatically. Using the information that we have in the YAML file, generating the Python file with the DAG is quite easy because you have already all the operators that you need to use and you have the parameters. So the complex part of choosing what is the right operator for the action that the user wanted to do, it has been done already before by the UI. Now, the YAML file processor, the only thing that does is go task by task, is grabbing what Airflow operator I have to use, and is taking the configuration parameters that were introduced by the user. So if I go to the one before, basically what the process is doing is like, these are my default arguments, and I go task by task, and I say, what Airflow operator I have to use? This one. Okay, happy days. What are the parameters that I have to pass? This, and this. Happy days. Boom. So this is what our YAML file processor does. Once that is finished, what we have as an output is the typical Python file with your DAG and with all the tasks that you want to execute there. So the last step is our YAML file processor put this file in the DAG folder of Airflow. So you have at the beginning one user introducing in a UI the parameters and the action that we want to execute, and the output at the end is a DAG in Airflow that is already scheduled and is already ready to be executed. So what are the main benefits and achievements that we had with this approach? So as Hendrik was talking before, the first one is that we are empower users for creating DAGs from zero and with zero code. So this is key because many of the users that we have in our central application, they are business intelligent users. They are users that they are not familiar with Python code. So I know that 99% of the people that are seeing this talk, they know how to code Python. But you have to keep in mind that the people that are expert in creating beautiful visualizations, they may not be that good with Python. And for them, creating a DAG, maybe a block or maybe even like a challenge or a nightmare. So with this approach, basically we are empowering our users to just say like, look, I don't want to code. I have data in SQL Server, I have data in Oracle, and I want to join this table with this table and put the output here. And this output is what is being the input of my dashboard. I am also creating dashboards, but I don't know how to do all of this. I'm just going to tell you what is the data that I want to move, where I want you to put it. Behind the scenes, do your magic. I don't mind how you do it. So we are empowering users to do this with zero coding. Additionally, we are offering data transformation and data loading on demand. Imagine that you are a very basic user from an IT point of view, and you are creating a dashboard, and you need to include in that dashboard information that you have in an Excel file or in a CSV file, in a flat file. We are offering the possibility that without any knowledge, this user goes and say like, look, I have Excel in this FTP folder. I just want you to load it into SQL Server, and then I will connect my dashboard. I don't know how to do this part. Make it happen behind the scenes, and then I will just connect to the table with the data. This is something that we are offering. So basically, we are unblocking our users. Before of this, you have typical requests in which a user say like, I can't do my job because I need data from here, here, and here, and there is nobody free or with capacity to make it happen. Right now, what is happening is that they are going to the UI, and in the UI, they say like, I have data here, 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 put it here, and then I will connect my dashboard. Don't worry for the rest. So all of that are the main benefits that we have. We are democratizing the access to ETL. Basically, everybody can create now an ETL with no coding skills. Finally, and this is a big one as well, if you are talking with business, we are saving money in licenses. So we are huge fans of open source. In our organization, we are trying to use open source as much as possible. One of the main benefits, not the only one, the unique, but one of the benefits is that we are saving money with in licenses. Before, we were paying an amount of money for licenses in Alteryx. Now, using Airflow is free. We are not paying any licenses. So finally, and for finishing the talk, I'm not gonna lie, not everything was that easy. So there are some challenges that we face it. There are some issues that we have had building this process. So I will go through them, and hopefully, if you try to replicate a similar process, you don't have the same challenges that us, or you don't have the same issues than us. So the first one, and we saw this very soon, is that you need to make easier for the user to modify an old DAG. This is what I was talking before about the version control. We found it that is a very recurrent use case that a user wants to modify a data pipeline that he created in the past. So you need to make easier for them to go to a pipeline and say, like, you remember this pipeline that I created 10 days ago? I need to modify. I need to add a new data source, or I have another requirement, I have to change it. So this is something that we found it later after the first version, but it's something that is key, is how you orchestrate it behind the scenes. For the user being able to modify this DAG is essential. And you need to be able to provide to the user the possibility of going back in time and changing the versions. Second, this is not more than a challenge. This is the problem when you are successful. So we create the UI, we make easier for everybody to create their data pipelines. What is now the main problem? It's like, as Hendrik said before, we have plenty of different databases. SQL Server, Oracle Teradata, MongoDB, Neo4j, Tiger Graph, Hadoop. We have plenty of different databases. What is the main problem? That we started with the minimum amount of databases that we wanted to support. So you have like SQL Server, you have Oracle. Now our problem is that users are coming to us and saying like, I don't find the option for loading data from MongoDB using your UI. So we need now to create all the Airflow operators behind the scenes in order to give that possibility, to create them for those ones that doesn't exist. But obviously, this is a problem that you have when you are successful. The third one, basically, as we started with this application, we are using the Airflow server as the orchestrator and as the executor of the Python code behind the scenes. We know that this is a bad practice. I know that this is not how it should be. I know that we should separate it, the Airflow as an orchestrator from the execution of the code. So something that we have tested in my area is to use Airflow for executing a Spark code using Kubernetes and Docker. So basically you have Airflow, it's the orchestrator, each task that you want to execute something, you connect to Kubernetes, you spin up your Docker instances, you execute the task, and then you kill your Docker instances. So this is where we think that we should move. It's something that we have in mind. We know that using Airflow for orchestrating and executing is wrong. It's something that we did it at the beginning, and we are moving now to use Kubernetes and Docker. So the main idea is that if you need to do a transformation, you spin up your Docker instance, this Docker instance do the transformation, and then you go to the next task. And finally, we found it that our users need to work sometimes in collaboration. So something that, for example, if you are familiar with Google Docs or with the new Microsoft Office, like just know that you are able to connect both of you at the same time in the team and work at the same time in the same Word document, for example. So some problem that we have found is that we have users that they are working in big projects and they are creating a data pipeline between 2, 3, or 4 users. So the main problem is that when they want to work at the same time, this is something that we didn't think at the beginning in our use case, and it's something that we have to include now. The possibility of several users being working in the same DAG at the same time and being able to generate that data pipeline in a more collaborative way. So it's one of the challenges that we have now, and it's something in which we have to work. So yeah, I think that I am within time. So this is the main challenges that we found it, the main issues that we try to overcome, and we are still working now. And I hope that you got some learning from what we tried to do, from what we did. And now we will answer any question that you may have. If not, you can always contact with us offline, and we are happy to go even deeper and talk a little bit more about this.
Okay. Thank you. A big thank you to Hendrik and Vicente for the insightful talk on using Airflow as an ETL tool. So we can move on to the QA session, and we have quite a few questions from the audience. The first question is, what is the software stack used for creating the ETL builder?
Yes, the ETL builder, I can talk from the part behind the scenes for the YAML file generator. That is the one in which I was more involved, and maybe Hendrik can talk a little bit more from the UI point of view. So from behind the scenes, what we are using is full Python. We have Python code, is the one that is reading the YAML, and is the one that is generating the DAG files. For all the execution within the database, is moving data, everything is Python. So this is what is using behind the scenes, but Hendrik maybe can give a little bit more of information about the front end. You are maybe on mute, Hendrik?
There we go. No, it's really nothing out of the ordinary. It's a React app with Node.js, and it really doesn't do much than capture that user input in the different dropdowns, which are just standard components, and then output the YAML file to predefined file system location that never changes.
Okay, thank you. So let's move on to the second question. So it says ETL looks like very useful for now non-dev users. So do you plan to contribute it to the Airflow community or publish as open source? And it
Yeah,
says like even only YAML Python converter without US will be useful for the users.
yes, it's something that we want to do, but we want to see what is the right way of doing it, because as you can imagine, everything that we create is within the IP of our organization. So I know that it's possible to do it within our organization, to commit to the open source community and to make it free to everybody. The only thing is that you have to follow a very specific path for how to do it. So this is why it's not done yet. The other thing is that we are still working in the next version. I don't think that makes sense to publish something to the community that is not 100% stable. I think that it may cause more problems than help. You don't want me to publish something that is between versions, and then you put it in your organization and everything starts falling and everything starts burning, and you're like, oh my God, why I am using this tool at all? So we need to go to the next version. The challenges that I was talking is something that we are using to improve to our version, using Kubernetes, Docker, using this collaborative approach. We need to get into that stable version before releasing it to everybody. So basically, if we do it, we want to be able to help you and not actually to give you even more problems trying to use it.
Okay, so hopefully we will be looking forward to see that all the features in
Additionally, we have to find like a very good and nice name. So that is a problem. I'm thinking in something very epic, but we need to find something really, really punchy for putting there with the name.
Okay, so we have 3 more questions. So the next question is, can the ETL tool have multiple input sources and join them?
Yep, you can have different tables within SQL Server. Oracle, I think as well, that is an option. So basically what you can do is to choose as a source and destination your different inputs, destination, different tables within the same database, and then in the transformation, what you can do is doing the join of the 3 inputs, for example, and point the output to what would be your final table. So yes, that is an option. The only thing is that because our building blocks, we try to make them as basic as possible, you have to do it like that. You have to do input 1, input 2, input 3, and then transformation, joining the 3 inputs.
Okay. So it can be done.
Yep.
Thanks, Rod. So the next question is, are tasks defined in the tasks section in a YAML file executed sequentially, or users can define more complicated deck by YAML?
As now, they are sequentially. I know that we are losing the part of being able to execute it in parallel, but this is tricky. The way in which we have done it is very easy to set up dependencies, because basically, like, you put it one after other, you know that they are dependent one on another. If you want to be able to do it parallel, I have found with junior users of Airflow, not the UI, Airflow itself, that sometimes it's a little bit tricky for them to set up properly the dependencies in parallel tasks. I'm sure that when you started with Airflow, you found it the same, that doing these parallel dependencies when you have different tasks at the same time may be a little bit tricky for a beginner. So we want to do it right. Right now is in sequential. But yes, that is a good point, and maybe it makes sense for the future to do it in parallel.
Okay, another future feature came up. Thank you. So the last question is, are there any cases which data processing with SQL constricts, limits your requirements? If so, do you consider using Spark for data processing?
Unfortunately, yes. When you have big tables, we found it scenarios in which users, because they are not experts in SQL and they are not experts in data pipeline, so we are empowering them. But sometimes the main problem is that imagine that you have one table that is 20, 50 gigabytes of data, and you want to move it from A to B. So sometimes users forget to do the filtering in the source, and they try to do it later in the transformation. So that means that effectively you end up moving 50 gigabytes between servers. So that is a problem that we find sometimes for the way in which the users use the tool. As I said before, we are aware that maybe using a Spark would be faster and better. We have done already the testing for Airflow and spinning up Kubernetes Docker with Spark. So that is something that we do already in my area. Now the thing is how we include it in our DAG generator in a way in which if your data is higher than a threshold, you, instead of moving the data normally, you spin up a Spark and you say, I want like 20 workers in a Spark, do your magic, move the data from A to B. So we are almost there. We are almost there to have that in the UI. Until then, we are doing in the old way, and sometimes it's a problem. We have users that they go like, oh, a table with 50 gigabytes. Yes, move it from A to B. And you end up like moving 50 gigabytes between servers. And you're like, I don't know why my data pipeline is taking so much. You're like, I don't know. Like, well, you're moving 50 gigabytes of data. This is why it's taking so much.